Hello friends, this question is from the subjects of networks and in the topic of sinusoidal steady state analysis, and the question we need to find the output voltage V03. Okay, V03 which is across the inductor, 10 millihenry inductor, we need to find the voltage across this inductor basically. And the question says that the input current IT is 5 sin 1000 T, where 1000 is the omega frequency. Okay, our operating frequency of the circuit. So we have the capacitors, so we must have the reactance about the capacitor XC. We have inductor, so we must have the reactance across the inductor, which is XL. So let's find out the value XC. XC will be 1 upon j omega C, where omega is 1000, C is 50 microfarad. So 1 upon j omega C is minus 20 j ohms. Okay, similarly my XL will be j omega L. Omega is 1000, L is 10 millihenry, so omega L is will be J10 ohms. Okay, so now let's find out. It's a simple nodal analysis. We have two nodes V1 and V2. We need to apply the nodal. So apply the nodal at V1. Okay, apply the nodal at V1. We have an input current IT and two output paths. So let's apply the nodal. So it will be the minus 5 plus V1 minus 0 by 30 plus V1 minus V2 by 10. Here I am saying that algebraic sum of the current at node V1 is 0. So and similarly if I can apply the nodal at V2, so it will be V2 minus V1 by 10 plus V2 by minus J20 plus V2 by 10 plus 10J is equal to 0. So now we have two equations, two unknown V1 and V2. Let's solve it. You can by solving these two equations you will get the value of V1 as 75, the 0 volt 0 phase shift. V2 will have a 50 volt with phase difference of 0. It means that my V1 basically equal to the V1T will be equal to the 75 sine of 1000 T. We don't have any extra phase shift because phase difference is 0. So that's why our phi term will be 0, and my V2T will be equal to the 50 sine 1000 T. That will be my V2. We need to find the clearly V0. V0 is basically voltage across the its inductor. So the current of loop current is I0. Okay, this IT is basically, if I name this as a I0 current. Okay, so my V0 is basically equal to the J10 I0. Okay, where I0 is nothing but V2 by 10 plus 10J, or I can say that 50 by 10 plus 1 plus J, or I can say that 2.5 root 2 with an angle of minus 45 degree, right? So this is my I0, current I0. So now if I can find out the V0 which is J10 I0, the question has a lot of calculation. So now give the multiplication 10 with angle of 90 degree into 2.5 root 2 times angle of minus 45 degree, and this will be equal to the 35.36 with angle of 45 degree volt. My V0 will be 35.36 in the with angle of 45 degree, or my overall expression of V0 T will be 35.36 sine of 1000 T plus 45 degree volt. This is my output expression. So my output expression will be 35.36 sine of 1000 T with 45 degree. My correct option is option C. C is my correct option. Thank you.